So these are just a few extra sig fig rules that don't fall into the general rules in the last video. So the first rule is that if a number is written in scientific notation, all digits in the coefficient are significant. So if we look at these numbers down here, these are the coefficients. So whatever is before the times 10 to the power is considered to be the coefficient. So if we look at these values as written, all of the digits in the coefficient are significant. So I'll highlight those. So this one would have 3 sig figs, this one would have 3 sig figs, this one would have 2 sig figs, and this one would have 3 sig figs. So this becomes especially important when you are going from scientific notation to standard notation, or from standard notation to scientific notation. So let's change these into standard notation. So if we were going to change this one into standard notation, we have an exponent of 2 and it's positive, so we need to make this number bigger. So we're going to move the decimal over 2 spaces. So this value in standard notation would be 500. But as written, this value right here only has 1 sig fig. But we know that the true value has 3 significant figures. So we have to put a period at the end to signify that those zeros are also significant. That way, this number also has 3 sig figs. So let's look at the other ones. This one has an exponent of -4, so we need to move the decimal 4 to the left. 1, 2, 3, 4. So it looks like we'll have 3 zeros after the decimal. So we will have 0.000232. And then this one has 3 sig figs. So it matches the first one, so we're good there. Let's look at the next one. We have an exponent of 3, which means it's positive. We need to move it over 3. 1, 2, 3. So we're adding 2 more zeros. So we will have 3,000. Now, as this number is written, we would only have 1 sig fig. But we know that the value has 2 sig figs. So in this case, if we were to add a decimal at the end of the value, that would make this number actually have 4 sig figs. And we don't actually have 4 sig figs, we only have 2. So in your rare case like this, there's a couple different ways that people will notate this, and usually you're going to put a line above that 0, and that means that that's the last significant digit, and so this value would have 2 sig figs. In order to avoid this ambiguity in sig figs for trailing zeros, we like to just make sure that we write numbers like this in scientific notation, because it's easier to see that this value has 2 sig figs than to have this value and have this random little line above the 0. All right, let's look at our last one. So we have an exponent of -2, which means we need to move the decimal 2 to the left. 1, 2. So we'll have 1 0 before the value, so we'll have 0.01. And if I leave it like this, we only have 1 sig fig here, because remember, these leading zeros are not significant. Leading zeros are never significant. So this value would only have 1 sig fig, but we know that we have 3, which means we're actually going to write out the extra zeros after that 1. So we'll have 0.0100. And then since these are trailing zeros after the decimal, they are significant, so this value also has 3 sig figs. So that's the scientific notation sig fig rules. So let's look at our next sig fig rule, which is that exact values have an infinite number of sig figs. So exact values include something that you're counting. So these would be values that we've counted. So if I count that I have 14 apples, I know that I have exactly 14 apples, not 14.1 or 14.001 or 13.99999. I have exactly 14 apples. Same with shoes, exactly 2 shoes, right? So things that you count have an infinite number of sig figs. And when I'm tracking sig figs, I like to just put the infinity sign and say they have infinite sig figs. And then, so these are counted values. Counted values have our exact values. And then equivalencies are exact values. So these over here are equivalencies. So these are things that we know to be true, that there is 1,000 millimeters in 1 meter. There is 12 inches in 1 feet. So these are also exact numbers because there is exactly 1,000 millimeters in exactly 1 meter. And same with there's exactly 12 inches in exactly 1 foot. So when you have an equivalency like that, all of these have an infinite number of sig figs. Okay, so this does not only have 1 sig fig, and this doesn't have 1 sig fig. They have infinite number of sig figs because they're infinitely reliable numbers, like it's exact numbers, so they have an infinite number of sig figs.